the reason I record these is because now, as you guys know, it takes meeting notes for me. So the recap function in Teams is pretty good to take the meeting notes. So that's why I do it. But last time we met was on, I guess, the 22nd here. And we did have a couple of things in the DASH work group, especially one that we wanted to cover. I guess I'll let you guys go first. Is there anything you wanted to cover before we go through a list? Riff or Marianne or anyone?
Yeah, if if we have some time, like late in the meeting, I can present the HA session APIs.
Okay,
to see if that, yeah, how that looks.
Why don't you do that first? If you'd like, it takes a little bit longer. Do you want to do that?
Yeah, sure.
Okay.
But if there is any things we'd like to go through,
Sure. Let's see here. So, just to let you guys know, Ashutosh from Intel has been kind of going through in the background and working through a couple of these, whether they're P4 or BMV2 kind of issues. And so we've been doing that. And I was hoping to work with Riff, Marianne, and Wei at some point in the future here to go through these. So, but we can let you go ahead and go first, Riff, if you like, because that might be a little bit more interesting.
Yeah, sure. Yeah, I think I also did some of the changes around the list.
Okay.
Yeah, but okay. Share my screen.
Thanks.
Sorry, Teams is having trouble.
I know, it's been a little bit clunky today.
Yeah. Okay.
You can see.
All right. So, okay. Thanks a lot. Okay. So this is pretty much the high availability APIs that from the the size perspective, how the APIs looks like to support the Dash like high availability in the ENI level HA. Okay. So so let's pretty much start. So the terminology not that interesting. Background is for supporting the high availability design. So this link goes to the current like HLD, and this is the ENI level HA. So the purpose of having this this HLD and this change is to actually have a flexible like the having a flexible like the infrastructure or the fundamental, so we can actually move forward to either implement the ENI level HLD or other mode of the HA. So yeah, so this is a starting point. The overall is that to support the HA, we actually have a few concepts like created here. So a few key components. On the high level, there is a HA set. HA set is defining the peer DPU, like a DPU pair, and how the data plan channel looks like for inline file sync. The HA scope. HA scope controls a fair of scope, and each HA set can have one or multiple HA scope. So, but each HA scope, like it controls if it's inactive, standby, standalone, and the reason why not directly using the HA set to to control why needs a HA scope like in the middle is because there are cases where one single HA set can have multiple HA scope, while each HA scope doesn't really hold only one single ENI. They could hold multiple ENIs. So there are actually the cases like that, which is why like the HA scope gets introduced here instead of directly using the HA set or the ENI. We use HA scope to add this flexibility here. The other thing is a flow table. the flow table is a very simple concept that serves as a container of all the flow entries. So it could be attached to a ENI, one single ENI, or all the ENIs in a single DPU. So that really depends on how the implementation looks like. But on the concept wise, it allows any of these combinations. It doesn't really have any restrictions on that. However, if it is not supported, then we can actually return false. For example, if you want to create two flow table, if the DPU doesn't support that, then we can actually return not supported. So then the HA scope could be connected to the high level concept in, for example, like ENI. In order to implement the ENI level HA, then each ENI will actually have a HA scope ID associated with it. Then in order to achieve the ENI level HA, say for example like switchover, then we can just control the HA scope, then HA scope attached to the ENI, which essentially changes the behavior of this ENI. Okay, so the topology is pretty much looks like this. So for example, DPU will have the HA set, and each HA set will have one or more HA scope, while each HA scope will have one or more like ENIs. So this is ENI level HA where one single DPU will have one single HA set because we are doing DPU pair, and then every single ENI will have its own HA scope. Each ENI will have, that means that each ENI could have its own active or standby. So, but all the ENIs are sharing the same flow table within the DPU. Okay. So, but
and that saves resources and avoids duplication of tables, that kind of thing.
Yeah. It also matches pretty much is trying to match what the underneath like the basic is doing, or the implementation is doing, because site pretty much should act as a slim layer while also provide the abstraction and flexibility. So yeah, that's why it is modeled like that. And then with this concept, not just implementing the ENI level HA, we can also do, for example, DPU level. Then we can just extend the HA scope to, both the entire DPU will have only one single HA scope. Then it will just work. And if we want to do even more crazy things, for example, like a multiple flow table within a single ENI and multiple HA scope within a single HA set, we can also do that. However, it is not required to implement this combination because, its abstraction is not a requirement to actually have all the possible like topologies supported. If it's not supported, then it's not supported. Also, the site can provide like capability, so we can actually model that as well. All right. So this is basically the high-level concept. Overall, we have the HA set, we have HA scope, and then we have this flow table. So these three things serve as the foundation of all the HA APIs. All right. Then to further illustrate how the concept looks like, here is the API design. And so HA set, because this defines a DPU pair and the data plan channel, so we can see the DPU pair and data plan channel. And of course, the data plan channel contains the DPU to DPU probe, so the probe settings will be still also here. HA scope controls the HA like the behavior. So for example, like HA row. So in this case, this is a typo. I will fix that later. So the HA row is basically the active standby or switching to active those states, and this is the HA row. The HA scope will have a back reference to the HA set ID that makes the HA set can support one or more HA scope. It also contains a flow version. This one is like for example, when we do a switchover, we actually need to increase the flow version. So the flow version is also included here.
Looks like we have a hand up, Riff. Is that okay to take questions now?
Yeah,
or
sure.
Do you want to save it to the end?
No.
Yeah, I had a question. I think
Yeah.
you kind of answered it, but I was just wondering this use case for creating multiple flow tables, right? And you said it's
Mm-hmm.
optional capability.
Yeah.
But I was thinking in the beginning, right, that the idea was to create a single flow table, which is
Yeah.
shared across all ENIs. So you don't have a hard code number of flow entries per ENI. So creating a single flow table is beneficial in the sense that because it's better sharing. So I was wondering what is the use case for creating a flow table per ENI?
Yeah. So it really depends on sorry. It really depends on the what is the requirement. For example, let's say we here is a complicated case. I don't know if you want to use this one as an example, but we could say, okay, one single ENI could have like one single flow table. Okay, just one single flow table, and then flow table could have limitations. For example, how much like the number of flows we support for this single ENI. We can use this one as the to apply the restrictions or something like that, because this is abstraction, right? So it doesn't really enforces like the underneath the ASIC have to use separate flow table or a single flow table, as long as it can serve as it can be translated into the core. For example, if one ENI has one single flow table and underneath is a shared flow table, then pretty much just add the ENI MAC to the key, and that will just work.
But
and
would you
also,
expect like a higher scale from so that's like for example in implementation can easily do it, right? You can just in the implementation say that I will force the source and destination port to be 0, and then 5-tuple flow table becomes a 3-tuple flow table.
Yeah.
But from a customer point of view, would you expect to get a higher scale now because that your key is only 3-tuple versus 5-tuple, or it's not important? The scale is not important.
That's exactly why. So, for example, if we create 3-tuple flows, 5-tuple flows for every single flow, we'll have a huge number of flows, right? But in some cases, we don't really need a 5-tuple flow. So 3-tuple flow probably is already enough. So having this flow concept, having this flow table concept like as simple as possible, it can allow us to do all these combinations in the future. Also, I'll take one example. Say we need like different maximum flow, because like the DPU is shared for all the ENIs, right? We don't want like each ENI to step on each other's toe. One of the things we could do is that, okay, for each flow table, we can actually have a maximum number of flows that can created for this ENI or for this flow table. So we can actually have all this like isolation mechanism like supported like very naturally. So for example, here we can have say some A number of flows for the 3-tuple, while B number of flows for the 5-tuple. Does that make sense?
Okay. So you can count them definitely.
Yeah, you can.
Okay.
Yep.
You can create customers with big ENI versus small ENI, that kind of.
Yep, exactly.
Okay.
And all this like CRM, everything will just like naturally supported because we have this flow table concept, we have the flow concept. So yeah, like all
it's
the
like a
things
logical
naturally
concept,
fit.
Yeah, it's like a logical concept. It doesn't have to translate to this individual flow tables in the hardware. It's a logical concept, and it can be mapped to a physical table in hardware. Okay, got it. Thanks.
Yep, thank you. Okay, and that's the basic concept of like the things that forms HA APIs. All right. So then we were in a flow scope, and this is pretty much the flow scope. Yeah. So the flow table, we just talked about it, and the flow. So every single flow, this is here we only shows the flow that is related to the HA behaviors. For example, the flow sync state, which essentially is a miss, created, sync, and pending. So what does those state actually do is that initially when the flow is not created, the flow is well, it's a default value. So if we try to find a flow that flow doesn't exist, is pretty much a flow. So in the API, we probably never get this one, because when we try to get a flow back, say there is a get entry, right? We get entry back and then flow doesn't exist, and then we probably will get like 0 as coming back. Count as 0 as out parameters. So the flow miss is more like a placeholder, but it's just making the the state machine and also internal representation like very easy to implement. We'll see that very soon when we talk about the behavior model. Okay, so behavior model here. And so in here, starting from the flow means when flow is getting created, it goes to flow created. And when the flow, we receive the flow sync ACK, then it goes to synced state. If flow gets resimulated, it will goes back to flow created because we need to sync it again. If it also, this is a logical state machine. So if it is a synced state, and if it gets a delete, then it goes to pending delete because the delete also needs an ACK. And the pending delete, when ACK received, it goes deleted. So pretty much goes back to flow means. So that's how the logical like states works. Yeah, for the flow sync state. So on the ENI, this is the last piece of puzzle to connect everything. So ENI will only have like one single HA scope ID that points back to the HA scope. And this one should be moved up. I will move it up later. But this is the HA row, which goes to the HA scope. Yeah, and this is pretty much the dead, active, standby, standalone, which is all the HA states that we defined in the HLD. Okay. The last one is the event notification, which means that whenever the state gets changed, we'll have to send out a notify. The notify function is attached to the switch extension as this attribute, and yeah, this is pretty much the event type, and this is event data, and the callback function is just like the standard like SCI event callback function that pretty much everyone is doing. Well, there are a few corner cases, but pretty much everyone is doing like this. Okay. All right. The counters will have a lot of counters. So I'll skip those counters for now because yeah, those are pretty much counters like tracking the inline sync status or traffic counters or flow operations like the heap counters, how much flow gets created, deleted, and sort of things. So I'll skip it for now. All right. Then on the high level, how the HA looks like. So in order to to demonstrate how the HA looks like, here is how the HA is going to be implemented in the behavior model. Today is not implemented yet because there are like pending works. For example, like data plan app is not there yet. So there are some pieces that it's currently missing, but the design is mostly like this. So I'll go through the design. The first of all is that to do the HA, we'll have a HA stage. That the HA stage can be considered as a substage of the contract lookup stage, or it can be a stage that follows the contract lookup stage. So pretty much like that. The reason why it's a substage is because right now in the Dash, like the behavior, when we say the contract lookup gets hit, it will go to the fast pass, which bypasses further stages. That's why like if we follow that, then HA stage will be bypassed, and then it will not work because we still need to do the flow sync, like the yeah, we still need to do the flow sync, and the flow sync will be bypassed if we interpret it like that. Then so on the high level, how it actually gets all the HA related information is that when the packet arrives to the pipeline, it will first from the ENI picks up the HA scope ID and flow table ID. Oh, I probably missed an attribute in the flow table. Yeah, so it will pick up the HA scope ID and flow table ID. Then from the flow table, it will actually pick up the flow from the flow table. And then from the HA scope ID, from the HA scope ID, it will pick up the HA set ID, HA row, and the flow version for the new flow, just like we showed here in the HA scope. And then, then from the now we have the HA set ID. Now from the HA set, we can pick up the peer DP information. Like the local IP, like the remote IP or peer IP, so we can actually create a tunnel for create a tunnel for the flow sync packets. Okay, and then to actually help the implementation, we'll have a few like the packet type and flow operations gets introduced in the behavior model. For example, in here, we'll have packet source. So we know it is coming from the external or coming from the peer or the data plan app, like local circulation. The packet type will have a regular, which is coming from the external, or is it the flow sync packets that we are doing for the HA. The last one is the flow sync. So we can say, okay, let's sync the flow create. This is a new flow. For the flow update, it is a flow resimulation. When flow is changed or some other things causing the flow being changed, then we sync the flow update. So it is slightly different from the flow create, because flow create expect the flow is missing. However, the flow update expect flow exists. Then the last one is the flow delete, which when we do the thing reset, will actually delete the flow from the peer. So then with all the ingredients, now we can have the overall like level packet like shows here. I'll go through the level packet like one by one following the lines, and the detailed explanation is actually like put in here. So but in here we will just like use a graph to walk through the steps. Okay, starting from the green line, the packet goes in like from here, and then it will go to the ENI look, go through the parser, go through the ENI lookup, finding the pipeline, and then in here we will see the first step is to get the flow, and the flow here will say, oh, it's a flow miss. I'm not hitting any flows. Then it goes to HA. HA will see, oh, I'm in active row. And the flow is missed. So I need to create a flow, which let the packet go through the rest of the pipeline. So it goes into all the match stages and it evaluates all the policies. But in the behavior model, doesn't mean in the ASIC, but in the behavior model, we will not directly go to apply the actions. We will take all these parameters like lookup result, goes all the way to trap it to the data plan. The data plan app will get the result and say, oh, I get the lookup result. I know what flow we need to create. So instead of modifying the packet directly, it will call the flow API, which is the second part of the HA design, which will follow up later, and call the flow API to insert the flow entry with in a not synced state, which is created state, and goes into the flow table. Then it recirculates the packet back to the pipeline. So now, when the packet gets recirculated, we know the source. So it goes through the parser. Parser tells the source, goes to the ENI lookup, and goes to the flow table. Flow table will get flow hit, and the flow state is created. Yeah. And then it goes to active. Active will, HA. HA will see, oh, I'm in active row. Flow is not synced. A packet is coming, so I'm going to change that packet to add an extra incap, and which makes it a flow sync request, then go into the underlay routing, which is pretty much forwarded to the standby.
Hey, Riff, sorry, can I interrupt you for a second?
Oh yeah, sure.
Like, I think my understanding of the HA could be wrong, was that when the first packet comes, right, we don't learn it. We actually send it to the peer, and let the peer learn it. And when the ACK comes back, then we learn it. And that makes sure that if the packet got dropped into, to the peer or from the peer, we don't learn the flow. But in the flow you described, you will actually learn the flow before peer learns it. So it doesn't match with my understanding. Oh
yeah, so I can explain a little bit. So it's not about learn the flow. It's actually about activate the flow. But activation means that the final packet could not be sent out before the flow gets activated or gets act. So in here, when we do the first round of the circulation, the flow gets created in a created state. So we will never forward the packet out until the flow gets acted. Yes. You understand is absolutely correct. It's just like the matters. Yep, no problem. And then once the packet we are in a forward, and now it goes to standby. The standby goes through the parser. The parser will know it's coming from the data plan. It's coming from the peer, and it is a flow sync request. And now it goes into the flow table. Flow table says it is flow miss, HA will see it as a standby, and it knows it's coming from here is a flow sync request, so it will sync the flow. Then because it cannot directly update the contract like a flow table, it will trap it back to the data plan app. The data plan app will insert the flow. However, in this case, because it's standby, it will insert into the table as synced state. Then the data plan app recirculates the packet back to the parser. Parser knows it's coming from the data plan app, and it is a flow sync request. So it goes to the HA. HA will see, oh, the flow is already synced. It is a flow sync request, and I'm in the standby state. So I'm going to transform it to a flow sync ACK and forward back to the active. When the active receives the packet, it goes through the parser. It knows from the peer, it's a flow sync ACK, and it goes to the flow table. Flow table is the flow is in a created state. HA is active role. So in this case, HA will transform it, or not transform it. Sorry, it will actually need to notify the data plan app to get this packet. To get the flow state changed into a synced state. So it follows this blue line, goes to the data plan app, updates the flow table to the synced state, and then recirculate the packet back to the parser. The parser will now see it coming from the local data plan app, and then it goes to the flow table in the synced state. That means everything is done. HA will see it's in the active state. So HA, that means that all the workflow is done. So following with the purple line, it will now bypass all the match stages because we only trust the initial ones, right? In active, we should not change the flow decision once it is like evaluated. So we bypass all the match stages, apply all the flow actions, like in the end, then forward it out to the pipeline. So with this, like the packet flow, it pretty much demos an example of how the HA gets, or how the inline sync gets implemented. Okay, so that is pretty much the workflow. And here are the detailed steps that I went through. Yeah, it's pretty much the same thing. Okay, so far any questions? Okay, sounds good.
Nothing in chat.
Yeah, hopefully that's a good sign.
Yes.
And, yeah. Okay, and then let's go to the final workflows. So this is pretty much how the HA like the session API gets called. For example, when we do the failover, or we do the HA set creation, ENI creation, or unplanned failover or recovery. And how it looks like is that here the graph shows here only shows the side API, the sequence of the side API calls. It doesn't show the full end-to-end, like the high-level workflows, like how the HA manage DE and everything, like doing the handshake and everything. So the full workflow is being linked here. So every single workflow here, we added a link, so to point to the full flow. So, but in order to support that, the full workflow, here is how the side API calls looks like. And so let's start from the HA set ENI creation. In this case, the SDN controller will first create the HA set on all the switches, then it goes to the switch 0 MPU, switch 1 MPU. And then from here, the MPU will actually call the side, sorry, not call side directly, but it will process the HA set and eventually cause the side API gets called, and it is called create HA set. And then same thing happens on the DPU, and the HA set only defines the DPU pair, so it doesn't have any rows inside. And then once this one is done, the DPU will start like data bus probe, the PMON, everything will start working. And after this, ENI can be created. Then SDN controller will start creating the ENI. And once the ENI is created, first it will be created in the data state, because before the policy is applied, we cannot actually run the ENI. So it will create it in the data state. So once the data state, once the ENI gets created, it will also create the ENI using the side, and eventually with the HA scope ID, sorry, this is HA scope ID as a data row. And then this one, this one goes to the DPU. This one goes to the same thing goes to the other DPU. And now it programs the SDN policy. And after all the policy is done, SDN controller will say, okay, let's change the desired state to active. Once it's changed to the active, then HA manager D will start to drive the HA machine, eventually first cause the standby row being set, and then cause the active row being set. Sorry, I'll fix the side API cost later. But this is essentially how the things looks like. And then in the end, the HA manager D will continue to drive the state machine and updates all the next hop in all the switches. And that's how the traffic gets flowed to the active side of the DPU. Okay, so this is pretty much the high-level workflow. And for the switchover, is very similar. It's just that, for example, here so the DPU 0 was in the active state. Now it's changing to the standby state. So what the SDN controller would do is to update the ENI state. So this one updates to empty, and this one updates to active. And once it updates to active, and we'll see like the state gets changed, then HA manager D will start to get a switchover approval and start to drive the state machine. Then once it started to drive, it will update the ENI on the standby side of the row to the switching to active row for the preparation. Then move this one to the standby row, then move the other side to the active row, and then updates the next hop and completes the process. The failover is also fairly straightforward because essentially is that the PMON will detect the DPU 0, like this DPU is dead, and then it triggers as a health signal goes to the HA manager D, and then HA manager D will start to drive the HA state machine to move the paired DPU into a standalone state. So it moves this one to the standalone state. And in the end, the recovery. The recovery is pretty much the same as launch a new ENI or DPU with the other side running as a standalone peer, which means that, for example, if this DPU is coming back from the dead, and then the DPU will actually create, because it will already have all the policies. If it already has these policies, then it will directly create the HA set and then do the reconcile with SDN controller. And in this case, the first once this during this process, the ENI will be created as a dead row, and with all the policies gets programmed, then state machine will get driven and eventually sets the new DPU as a standby, while then later on changes the standalone side of the DPU to active. And in here, there is a bulk sync, other things like gets in the middle. Okay, so that's pretty much how it looks like from the HA session, like side API point of view, how the workflows looks like. Okay, so far, any questions? I'm also not seeing any hand.
Riff, I'm not sure if you were going to cover this later, but are you going to talk about how this may or may not work in the BMV2 model?
Oh, this one?
Are you going to implement this and run tests somehow?
Yep.
Or,
yep. Okay. Because setting the the rows and change. Yeah, here as we can see, pretty much is changing the rows and creating the HA set and everything. So this one can be, and all the level packet can be all implemented in the P4. I actually have a branch right now with all the things like as a prototype. But
I see. and are you going to write some unit tests or functional tests for this as well?
Yep. Okay. And eventually, the plan is that the idea is to actually have a virtual DPU image that can be run even with a management test. So then it will be really nice to have.
Wow. Do you plan to run somehow model 2 DPUs connected together and do test?
Yeah.
Wow, that's ambitious.
Yeah, that's ambitious, but we'll see step by step. Okay. Hopefully.
Excellent.
Yeah, Yep, and this is the P4. This is the HA stage that shows the how the table looks like. So although it doesn't implement the state machine right now, so state machine transition is not implemented, but all the required information is actually here already. And then in the other repos, so this one is not shared yet. But this is the other repo. It's not synced yet. Still have some old code, but in here we'll see like how the state machine gets implemented, and then how the HA gets implemented on each of every row. So it's pretty much the sorry. It's pretty much a state like the design pattern. So each state will have its own, and it handles like the flows in different state and then do the thing like differently. So it is still using the old contract, it's not synced yet, but I think this will demo the idea. So this is some the work I'm doing currently in parallel.
I see.
Okay, so hopefully that works. And then in the PR, all the APIs are actually. Oh, oops, sorry, bad. In the PR, in the description, here. Yeah, the CI is currently failing because of some minor issues in the generated side, like at range keyword is missing, that sort of things. But I'll get that fixed later. And in here we'll see all the APIs. For example, like dash HA here. Oh, come on. Which will have all the APIs here. So if we scroll down to the very end, we'll see all the HA set and the status, which has all the counters, and the HA scope. This is the HA scope, like APIs, and on the ENI, we'll see the yeah, there we go. On the ENI, we'll see the HA scope ID here. And this is the HA scope ID. I think this one needs to be changed to the object, but it's not changed yet. Okay, so but that's pretty much the high level for the whole HA design, like the API design. So hopefully that should have a fairly good foundation for the future work. Okay, so if any questions, feel free to let me know. I'm always open for any discussion. Okay, that's pretty much everything. Yeah. Thanks.
Thanks, that's pretty elaborate.
Thank you.
Thanks, Riff.
Yeah, thank you. Okay. Yeah, I'll stop sharing. Sorry, Christina. Yeah, it's all yours again.
Okay, so I'm virtual Christina. She left the meeting a while ago. Anyone, any discussion or comments regarding what Riff just presented? So Riff, do you have any kind of time frame in mind for, let's say, seeing this in a pull request or a demo or something? You think you want to do a demo when you got more working?
Yeah, I think first of all, if it is okay, we can get API checked in, and then we can all do the following work in parallel. And then if it is possible, like we can probably target this one next week to get the API checked in, and then I will work on the like a P4 part of things. And once the P4 is ready, yeah, we can do a demo definitely. Yeah, but that will take some time because the data plan app needs some needs some work over there. But the P4 code is fairly relatively, comparing to the data plan app, is fairly straightforward to write.
Do you feel comfortable submitting the API change like this without having a little more proof that it works and meets the requirements, or you just would handle changes in the future as another PR?
So I think we had this one communicated with some folks and I think Marian is here. So we pretty much have, you
have a bit of a back channel consensus that seems okay. It's not just a pure science project.
Yeah, it's not pure science. Yeah. It needs to be like synced, and so people will actually knows like what is going on. So there are a few back channels over there, and as a preview. So, and of course, it's not like we definitely need like sign-offs, like approvals. So it's not like, we stop it over there and just can directly check the thing. So we'll get the relevant party sign off for sure.
Okay, that's good to know that there's some vetting going on, because it's pretty complicated enhancement. Worthwhile.
Yeah, that's HA is fun.
Yeah.
Yep.
Mircea here. Once this will be implemented, we will have interoperability between vendors if everybody implements this?
Mm-hmm. Yeah.
Or this doesn't assume interoperability?
At least, so if they implement the same mode, say they all implement the ENI level HA, then you should have interoperability.
Hold on, Riff. I don't think that's true. Because if you look at the packet replication, flow replication. In order to do the flow replication, you need to pass metadata between active and backup, and it's not a standardized thing. So there is no assumption for interoperability.
So the API could be actually in the Flow API we have a field called vendor metadata. So it's really like if you have any like private metadata, we can always put it over there. So by vendor interoperability, I don't mean like the inline sync will actually work. Say we have two DPUs from like different vendors. That is not going to work because they are like private like metadata. By vendor interoperability means that if it is the same, like we are having the same like the DPUs from the same vendor, and we call the APIs, and then should work. It should not differs in that case. Does that make sense? But yeah, we don't have any restrictions on how the the metadata looks like.
Understood. Thank you.
Yeah, so it should always integrate with Sonic the same way from vendor to vendor, but there'll be some opaque data that's passed between vendor implementations.
Yeah, that's totally fine.
Yeah.
Yeah. Otherwise, that would be very hard to do. Yeah. I agree. Okay.
Thanks a lot.
Yeah. Thanks.
So, does anybody have any other topics or issues they'd like to discuss? So I've been in touch with Andy Fingerhut, who couldn't make it to this meeting, but he told me that he's making more progress on P4 DPDK for Dash, and he's now peeling the layers of the onion. He's got to the point where some of his initial test where he tries to set things up with P4 runtime, he's finding P4 runtime issues in P4 DPDK once he starts going for the Dash use case, and he's filed some issues with P4 DPDK, and that team is aware of the issues, so they'll look at those and see if they can close the gaps. So work proceeds. Okay, well, it seems like we're at a meeting close here, and I'll try to stop the recording. I can figure it out. Doesn't look like I have the power to do so, but I think if I end the meeting, then the recording will stop. So unless there's any final thoughts, we can end the meeting now, and we'll see each other in 2 weeks at the next behavioral model meeting. Okay, thank you, everybody. Have a good day.
Thank you.
Bye-bye.
Thank you. Thank you. Bye.